This lesson is on equations of tangent lines and normal lines for calculus. So what two things do we always need for a linear equation no matter what level of math that we're in? We need a point and we need a slope. If we have those two things, we can figure out the equation of a line. In this class, we are going to use point-slope form a lot. That's what we're going to make our tangent line equations and our normal line equations with. Point-slope form says y minus y1 equals mx minus x1. But I don't want you to necessarily have to remember the x1s and the y1s and the m's. I want you to remember how to set it up and then fill in the blanks. So you'll always set it up y minus on one side and x minus on the other. The x minus will be in parentheses. Just don't forget to leave space before it. You'll fill in this part with the y value, this part with the x value, so y goes with y and x goes with x, and then your slope will go in front of the parentheses when you plug those things in. Okay, the way we're going to get those things, since we're in calculus, we are going to get the slope of our tangent line by taking the derivative and plugging in x, because the derivative is the slope of the tangent line, and we're going to be wanting it at a specific point, so we will plug in the x value of that point, and that will give us the slope right there. The point may be totally given to you. They may give you the entire x and y value, but if they just give you an x, the way you get the y is by plugging it into the original function. There will be other times in this class where we are looking for y values. Y values always come from plugging into the original function. So keep that in mind. Okay, for our first example, we're going to find the equation of a tangent line to y equals 3x squared plus 4x plus 2 at negative 1, 1. So we need the point and we need the slope. This one's pretty nice. They gave us the entire point. We don't have to do any work for it. The slope we find by taking the derivative. So I'm going to get 6x plus 4 and then plugging in our x value. So I'm going to do y prime of negative 1. That'll be 6 times negative 1 plus 4, so we get negative 2. So our slope is negative 2, our point is negative 1, 1. I come down and I write my point-slope form, and then I'm going to fill in the values. I'm going to start with the point. You put your x value with the x, so negative 1 is going to go right here, and the y value goes with the y, so 1 is going to go here. Slope will go in front of the parentheses, so that's where I put my negative 2. Now, the nice thing about the AP exam is you don't have to get it in y equals mx plus b. This is acceptable if they are just asking you for the equation of a tangent line on a free response problem. Now, in multiple choice problems, they may have it in y equals mx plus b, they may have it in standard form. You may have to work on this a little bit. But if you are in a free response question, you can leave it like this. I mean, you may want to change this to plus, but you can leave it in this form and get full credit. Okay, example 2, we want to find the equation of the tangent line to y equals 1/2 x squared minus 5x plus 7 at x equals 3. So again, I need two things. I need a point and a slope. With my point, this time they only gave me the x value. I need to find the y value. I'm going to find the y value by plugging into the original. So y will equal 1/2 3 squared minus 5 times 3 plus 7. And so that will give me negative 7/2 when I work that out. So my point is 3, negative 7/2. My slope, again, I take the derivative, because the derivative is the slope of the tangent line. So that will give me x minus 5. And then I plug in my x value, which is 3 in this case. So 3 minus 5 is negative 2. So again, I have a slope of negative 2, but I have a new point here. and it's a new function that we're being tangent to. So my equation, put my y minus, my equals, and my x minus. I'm going to fill in the y value with the y, the x value with the x, and the slope in front. When I do that, I can put this to a plus just so it makes a little bit of sense. And I can leave it like this. Okay, this is the first time that we've talked about normal lines. They are perpendicular to the tangent line. This is also related to normal forces for those of you in physics, because your normal force is always perpendicular to your surface. So if you see the word normal, then relate it with the word perpendicular. It probably has something to do with that. Since we can find the equation of a tangent line, we can also find the equation of a normal line. So first of all, let's kind of draw a picture of what it is. So if I have a function, and I'm talking about this point right here, I can put in a tangent line that may be this one. The normal line would be perpendicular to this tangent line, but go through that point. So I'm going to try to straighten that up to be a little more perpendicular. And so for what we're doing, that's the best we've got. They are perpendicular to each other. Again, this orange one is our tangent line to that particular point. The blue one is our normal line to that point. Now, you learned about perpendicular lines back in Algebra 1, Math 1, something like that, and you learned that their slopes are negative reciprocals. So the slope of the normal is the negative reciprocal of the tangent's slope. And so just to remind you what that means, if the slope of the tangent was 5, the normal would have a slope of negative 1/5. So this one was positive, it changed to negative, and you have to think of this as 5 over 1 and flip it. So you will flip it and change the sign. If this had been a negative 5, this would have been a positive 1/5. But again, that relationship is something that you learned a long time ago. We're just going to be using it now. Okay, for example 3, we're going to find both the equation of the tangent line and the normal line, and we're going to pull some trig in so that we're using all of our derivative type thinking skills. So we need, again, a point and a slope, and we're going to do the tangent line first. So our point, they give us the x value of pi over 2, and so I need the y value. So the y will be the sine of pi over 2, and this is where your unit circle is going to come in. If you remember the unit circle, pi over 2 is up here at 90 degrees, the same thing. That point is 0, 1, and the sine is the y value. So the sine of pi over 2 is 1. So there's our point. And then slope, we are going to do the derivative. So the derivative would be, derivative of sine is cosine. And again, we're going to plug in our x value, which is pi over 2. And since I already have that drawn, the cosine is the x value, and in that case it's 0. So we have a slope of 0. So our tangent line, we would put the y value in, the x value in, and a slope of 0. And you're like, okay, well 0 times that is all going to be 0. So you have y minus 1 equals 0, or y equals 1. And that makes sense. That just means it's a horizontal line, because a slope of 0 means it's a horizontal tangent line there. And also, if you're thinking about the graph of sine, it has that period of 2 pi. And so at pi over 2, you are at the top of a hill and the tangent line would be horizontal there. So that slope of 0 makes sense. And the equation of that line, y equals 1, also makes sense because the highest that hill is at 1. Okay, now we're going to do the normal line. The normal line is going to use the same point because they both cross at that same point. But it's going to use the negative reciprocal slope. Well, what's the negative reciprocal of 0? The opposite of 0 is kind of a special case, so it's undefined. And now you have to think to your toolbox functions, what kind of line has an undefined slope? Or think about my graph. If I did a vertical line right there, what would that equation be? And that would be x equals pi over 2. So this is kind of a special case. Your tangent line was y equals 1 and your normal line was x equals pi over 2 because they were perfectly horizontal and vertical lines. That happens once in a while, and that's either at the top of a hill or the bottom of a valley. Okay, since we've practiced several tangent lines, for number 4 we're just going to do the equation of a normal line. And they gave us the point 0, 3. And I need to find the tangent slope so that I can find the normal slope. So I'm going to go about the slope the same way I had been doing, but I don't use that one without fixing it. So my derivative would be negative 3x squared plus 4x plus 4. And then I'm plugging in the x value of 0. So negative 3 times 0 squared plus 4 times 0 plus 4 gives me 4. That's the slope of my tangent. That's not what I'm trying to find. So the slope of my normal would be perpendicular to that. And so if this is positive, the perpendicular slope will be negative. And I have to think of that as 4 over 1. And if I flip that, I get 1 over 4. So the slope of my normal is 1/4. The slope of my tangent is positive 4. And since I'm just writing the tangent line, I'm going to come down here, set up my point slope form, and then plug in y value with y, x value with x, and slope in front. And you can simplify if you want to, but again, you don't have to. Okay, for example 5, I'm going to change it up a little bit. I did ask you this type of question before we learned all of the derivative shortcut rules, and so this really makes you understand the derivative again. We have a function. We want to know where it has a horizontal tangent. What do you know if the tangent is horizontal? The slope is 0. Okay, if the slope is 0, then our derivative is 0 because the derivative is the slope of the tangent line. So basically I'm going to find my derivative and set it equal to 0. So my derivative in this case will be x squared minus 4. I'm going to set that equal to 0. This I can factor. It's a difference of perfect squares. So x minus 2 and x plus 2. And if I solve that, I get x equals positive 2 and x equals negative 2. What that means is there's 2 places where this function has horizontal tangent lines. One is when x equals 2, one is when x equals negative 2, and sometimes they might ask you for the point, like the whole point instead of just the x value, and if they do that, you get the y by plugging into the original. You always get the y value by plugging into the original. But in this case, it just says where, and where is a location on the x-axis. So we have answered this completely. And that concludes this lesson.